If we want to deal with sines and cosines of angles bigger than pi over 2, I obviously can't make a right triangle that has an angle of 150 degrees by pi over 6 or anything like that. But I can use kind of the geometry of the unit circle combined with the idea of we're on a coordinate plane and the x is our cosine and the y is our sine to find those coordinates. Let's see. So when we're at 2 pi over 3, I think horizontally I'm moving over the same amount that I moved horizontally to get to pi over 3. But because I have to move to the left to get to 2 pi over 3, I'm going to make it negative 1/2. Actually, everything in quadrant 2 will have a negative x coordinate. Moving negative 1/2 is the kind of smallest movement that's not 0. The next one over here is moving a little bit more than that. That would be negative root 2 over 2 for an x coordinate. 5 pi over 6 is moving a little more than that. That would be negative root 3 over 2, comma something. And pi would be negative 1, comma something. Filling in the y coordinates, well, at pi over 2, my y coordinate is 1. At 2 pi over 3, actually, I don't even have to think about it that way. I can think it a different way. At 2 pi over 3, I think my y coordinate is the same that my y coordinate is over here. It's root 3 over 2. What's my y coordinate here? Well, the same that my y coordinate was over there. It's root 2 over 2. What's my y coordinate here? I think it's going to be 1/2. And what's my y coordinate over here? 0. Why is this useful? Because now I can ask you things like, what's the sine of 2 pi over 3? Well, remember that the sine is the y coordinate. I'm just going to go to 2 pi over 3 over here and look at my y coordinate, and I can say it's root 3 over 2. Let me continue using this geometry to figure out the angle, the coordinates of the angles over here. 7 pi over 6 will have coordinates of negative root 3 over 2, comma negative 1/2. Over here I'm going to be negative root 2 over 2, comma negative root 2 over 2. 4 pi over 3, negative 1/2, comma negative root 3 over 2. 3 pi over 2, 0, comma negative 1. At 5 pi over 3, my coordinates are 1/2, comma negative root 3 over 2, because you're moving in the positive x direction, but the negative y direction. Over here, you've got negative root 2 over 2, root 2 over 2, comma negative root 2 over 2. Over here, you've got root 3 over 2, comma negative 1/2, and we end with 1, comma 0. This is our filled in unit circle, and this unit circle gives us all the information we need to find sines and cosines, but honestly, to find all the trig values of all the good angles around the unit circle. In your packet, you have the filled-in version. We will need to be able to know the coordinates. It will make all of the trig we deal with a lot easier if you can kind of logic your way through what the coordinates are going to be. Let me show you how we can now use this to find some sines and some cosines. First example. Let's go and find the sine of 5 pi over 6. Sine of 5 pi over 6. Well, I first need to be able to locate 5 pi over 6 around the unit circle. Hopefully you remember the tricks for figuring things out. I know over 6 is closest to horizontal, and I also know since my numerator is 1 less than the denominator, I'm in quadrant 2. I'm right over here. Here's 5 pi over 6. I need to know the sine. I need to know the y coordinate of this point. Well, I think the y coordinate here, my three options that are not 0 or 1 are 1/2, root 2 over 2, and root 3 over 2. I think this is going up the smallest amount, so I think this is going to be 1/2. The sine of 5 pi over 6 is 1/2. Next one, let's find the cosine of 7 pi over 4. First thing we're going to do, we're going to locate 7 pi over 4 around the unit circle. 7 pi over 4, right over here. I know over 4 is halfway directly in the middle of the quadrant. I know that if the numerator is 7, the denominator is 4. That means that numerator was 1 less than twice the denominator. I'm in quadrant 4. I'm right over here. Okay, I forgot what I was looking for. I was looking for the cosine of 7 pi over 4. Cosine is the x-coordinate. I need the x-coordinate of this point. My three options for angles in the middle of a quadrant are 1/2 root 2 over 2 and root 3 over 2. This is the one directly in the middle, so this needs to be root 2 over 2. The cosine of 7 pi over 4 is root 2 over 2. The sine of 4 pi over 3. Okay, well, let's locate 4 pi over 3 around our unit circle. 4 pi over 3, that's down here. I want the sine, that's the y-coordinate of this point. Let's see. I think I'm going down the most I can go down, so -1/2, negative root 2 over 2. No, this one's going to be negative root 3 over 2. And the sine of 4 pi over 3 is negative root 3 over 2. Finally, the cosine of pi. Where is pi around the unit circle? Pi is right over here. What's the cosine? What's my x-coordinate of this point? I think horizontally I'm going left 1. I think the cosine, therefore, needs to be -1.